Every year, more than 1.2 billion smartphones are sold worldwide. This means that, on average, almost 40 new devices are bought every second. With a market valued at over $460 billion, these devices have become the center of modern life, indispensable for work, communication, and entertainment all over the world. But do you know how they are made? Watch this video to see all the stages of smartphone manufacturing. It's important to understand that a smartphone is not built in a single factory. It is the result of a supply chain that extends all over the globe. Dozens of specialized companies in different countries manufacture individual components that only come together at the end of the process on a gigantic assembly line. Our story begins, therefore, not in a clean room, but in the depths of the earth. It all starts with extraction. The screen glass and the microchips, the heart of the device, come from silicon, which is purified from quartz sand. The battery relies heavily on lithium and cobalt, minerals extracted from very specific places on the planet. The casing is often made of aluminum, which comes from bauxite. And inside the circuits, we find copper for the traces and small but crucial amounts of gold for the connectors, chosen for its excellent conductivity and resistance to corrosion. In addition, there is a group of minerals known as rare earths, used to create the tiny magnets in the speakers and vibration motors, and also to refine the colors we see on the screen. This initial phase of mining and refining is a heavy industrial process, turning loads of raw rock into the purified metals and powders that component factories need. The most complex component of the entire smartphone is, without a doubt, the system on a chip. This is not just the processor, it's the complete brain of the device, integrating the central processing unit, the graphics processing unit, memory controllers, and the Wi-Fi and cellular controllers, all in a single piece of silicon. The manufacturing of these chips is an almost unbelievably precise process, carried out in places called foundries or semiconductor foundries. While the brain is being made, other crucial components are made in other factories. The screen, for example. The glass we use, often called strengthened glass, goes through a chemical process. Under this glass is the actual display panel, which is usually OLED or LED. Finally, the display panel, the touch-sensitive layer, the digitizer, and the protective glass are fused into a single piece, a high-precision sandwich. At the same time, the cameras are assembled. Smartphone camera modules are marvels of miniaturization. They consist of a set of tiny lenses made of high-quality plastic or glass that need to be perfectly aligned to focus the light. All of this is assembled in a small, clean room of its own. And of course, the battery. Most are lithium-ion. Now, we need a place to connect all of this. That place is the printed circuit board. It's that green board, or sometimes blue or black, that we see inside any electronic device. It works like the nervous system, connecting the processor to all the other components.
Processo semelhante à litografia.
It's used to print the circuit map on the board, with all the components ready: the chip, the screen, the battery, the cameras, and the bare board. They finally converge at the final assembly factory. This is where the phone comes to life, on a production line that mixes high-speed automation with precise human labor. The first step on the main assembly line is called surface mount technology. The printed circuit board will be passed through a machine that precisely applies solder paste to the spots where the components will go. Next, the board enters the pick-and-place machine. This is an incredibly fast robot with arms that pick up the components, the processor, the memory chips, and hundreds of tiny resistors and capacitors from their reels. And they place them in their exact spots on the solder paste. The board, now full of components, goes through a reflow oven. The heat is precisely controlled to melt the solder paste, which then solidifies. This permanently solders all the components in place and automated optical inspection cameras check each board to ensure that no component is out of place. Now, manual and semi-automated assembly begins. The phone's chassis, which may have been milled beforehand, receives the now complete board, which is then screwed or snapped into place. Workers or robots connect the larger components. Flexible ribbon cables, as thin as paper, are carefully fitted into tiny connectors to link the cameras, the side buttons, and the charging port. The vibration motor and the speakers are installed. The battery is one of the last components to go in, often secured with strong adhesive. Next, waterproof sealing adhesives, if the model has this feature, are meticulously applied to the edges of the casing. The display module is then connected and carefully pressed into place, sealing the device. The back cover is then attached and the smartphone and tape are installed. The soundboard and the flexible tape are installed. The soundboard and flexible tape are installed. The next step is the installation of the software. The phones are placed on racks and connected. The operating system, in this case Android, is flashed onto the internal memory. Along with the base operating system come the drivers, small pieces of software that tell the system how to use specific hardware, like the camera or the fingerprint sensor, and the manufacturer's custom interface. The phone is turned on for the first time. The process ends with a rigorous battery of quality control tests. Each phone goes through automated testing stations. A machine tests the Wi-Fi, Bluetooth, and cellular connection. Diagnostic software checks if all the sensors are working, the accelerometer, which detects movement, the gyroscope, which detects orientation, and the proximity sensor, which turns off the screen. The cameras are tested for focus, color, and smudge detection. In addition to testing every device, random samples from each batch are taken for durability testing. Robots simulate drops, machines try to bend the device, and chambers test water resistance. Phones that pass absolutely all the tests receive their final stickers, including the number that uniquely identifies the device on the global network. They are cleaned, get a protective film on the screen, and are placed in their retail boxes along with a cable, a manual, and a charger. And that was today's video. Don't forget to leave a like and subscribe to the channel.